Let's have a look now at 2014, question 9, part B. So this is one of our hydrostatic questions where an object is tied down underwater. Now, in this question, if we have a little peek at the question, we have quite a lot of information coming at us. So let's just lay it out bit by bit, and we have parts 1, 2 and 3, so we're not going to worry too much about 2 and 3 until we get through 1 and so on. So we have a chunk of water here, and there was a little water level originally in at 18 centimeters. And then we put this big yolk in. There it is, funny looking shape. We don't really care about the shape. All we care about is the volume. There we go. And the water level now rises to 24 centimeters. So it goes up. So the key thing here is that the change in height is 6 centimeters. And that is, of course, 0.06 meters. Because we are going to deal with densities. The density of this liquid here, rho, is 1,000 kilograms per meters cubed. So we need to watch our units. It's an easy way to get things all messed up on this one. Okay, what else do we know about this one? We know that there is a weight going down, and the weight equals 120 newtons. Happy days. We don't have to worry about gravity. It's all that conversion is done for us. Anything else we know? Yes, the distance here is x centimeters. All right, and it's a cube overall, so x by x by the height is going to be our total volume of water. Now, and that, of course, equals x by 10 to the minus 2 meters. All right, so x is our centimeters value, but we do need to convert 10 to the minus 2.001. All right, now that's our information in place. The rest of it isn't actually so bad. It's floating, so the buoyancy equals the weight. That's okay. And what about our buoyancy here? Well, our general equation, of course, is buoyancy equals v rho g. There we go. And volume, don't forget, is the volume of liquid displaced. So let's bring this all together. Well, we'll just flip that one around. 120. Let's look at the volume displaced here. Well, it's going to be x by 10 to the minus 2 all squared, because it's a cube base, by 0.06 by the density is 1,000 by g is 9.8. Okay. Now, so 120 is x squared by all of this stuff here. Okay, calculator time. Well, oops, straighten that back up again. 10 to the minus 2 is 1 exponential minus 2, and then we'll square that. There we go. By 0.06 by 1,000 by 9.8. And that is going to equal that delightful number there. 0.0588. Alright, so x squared is simply going to be 120 divided by 0.0588. I'm going to use my little store function here, so I'm going to store that into x, and then 120 divided by x is that delightful number there. So x equals square root. I'm going to put some of these numbers down just in case I made a slip in the calculator. Let's put that into decimals. 0.81. And we're going to see in the screen here we are indeed. X equals, so just store that into y in case I need it. Square root, we call y, 45. 45.2 centimeters. There's my x. Okay. Now, I might need this later on, so I'm going to store that into A. Just make a little note here that that's going to go into A. All right, part 1 finished. So what do we want to find next? Well, the tension in the string when the whole thing is underwater. So there we go. And the whole thing sits underwater. A little funky shaped object here. and it is held down by a tension in the string, and it has a weight going down. So the weight is 120, the tension is T, there is a buoyancy force going upwards, and our nice little bit of information is that the total height is now 32. Remember, before the object came in, it was 18, no object, and rose up to 32. So crucially, our change in height is 32 minus 18 is going to be 14 centimeters, which is of course 0.14 meters. Alright, now let's lay this out for a little minute. Forces up and forces down, up and down. Well, buoyancy equals tension plus 120. So the tension equals buoyancy minus 120. That's alright. Well, what about buoyancy? So buoyancy is V rho g. So in this case we have, let's say we have x by 10 to the minus 2. I'm just not writing the multiply by because it gets confusing with our x's. And that is all squared by 0.14 by 1000 by 9.8. Alright, let's see, can we figure this one out? So buoyancy is, now actually we do know a value for x, don't we, of course, because it's this one down here. So recall A by 1 to the minus 2. So there we are. Store that in B. So just to tidy that up a small bit, 0.4518, 0.14 1000 by 9.8. Okay, just forgot for a moment we had x. So in this case our buoyancy equals this squared by 0.14 by 280. Well, that's quite nice, isn't it? 280 newtons. Buoyancy is 280 newtons. That's not quite what we're asked for, but we're very close to it. So therefore tension equals 280 minus 120. So tension is 160 newtons. Okay, so that was part 2. Now our part 3 is the density of the body. Well, let's see how we can have a little look at that one. Density of the body, well, we know its weight, we know its volume, so this actually should work out rather nicely. Oops. Weight equals V rho g, and in this case that equals x squared by 0.14. Now at this point you might be getting a little bit tired of figuring out all your values in our x squareds, so you know what, there's a slightly easier way to go at this one. I'm going to look at this one as buoyancy is weight over s. Okay, so we know our buoyancy is 280, so for 280 equals 120 over s. So therefore we'll go across a bit because we're running short in space. So s equals 120 over 280, and that of course is going to be 3 over 7, but just in case you're getting tired and it's late in the day, we'll figure that out, and that's 3 over 7. Now that is not what we're being asked for though, so we've got to be a little bit careful here. We are asked for the density. Density of course is 1000 times s, because that's the relative density, so that is 1000 times 3 over 7. So we'll get another line, I think we'll go across this way just in case. 3 over 7 by 1000, and we get 428.6 kilograms per meter cubed. And there we have it. You could have solved it this way, but I was just getting tired with our exponentials. A bit of variety. Okay, it's always a couple of different ways when it comes to these questions.